Okay, here's some slides. This is the input to the device, the output of my computer, and here is the output of the device into the input of my amplifier speaker combination. Left and right channels, blue and green. The output versus input gain. The output right now it's at maximum, which is this right here, 100%. So when I say maximum, that's what I mean. When I say minimum, this is what I mean. When I say nominal or 50%, right here. So this is at 100%, and the outputs are adjusted to approximately the input level. So the input to the device is 5.27, the output is 5.2 to 5.3. 100%. I'll go down to from 100% to 90%. So the signal from the computer, the audio signal, is going down, as you can see here, but the output of the device is still, say, at 100%, it's 5.2, 5.3 volts. Audio going down, 5.4, 5.3. Volume going down, 2.8 volts, 5.7. So the output of the device is still hanging in there with some switching distortion. 70%. That's where this is now at this point. That's 70%. And look at the volume of the output of the device, the automatic volume control. 5.7, 5.6. The output's going down to 60%, 5.7, 5.7. The outputs, left and right channel. The output is now at 1.65 volts. The output of the device, 5.7, 5.8. The volume is now set at 40%, or 1.65 volts, peak to peak. The output at the left and right channel, 5.7, 5.8. The output now going down to approximately 30%, 880 millivolts. The output is now just beginning to show a little bit more distortion. This is, again, the switching frequency of that 300 kilohertz or 305 kilohertz, well beyond the audio range. So this has no effect on the audio. The audio of this is just as clear and as clean as you could expect. You don't hear any distortion. This is all out of the audio range, so you don't hear that. So anyway, so now the output of the AVC is now beginning to go down at 30%. At 20%, it's still hanging in there, but it's not at 5 volts, or 5.7. It's at 4.7, 5.1. Here I'm at 10%. The volume is almost completely turned off, and I still have in one channel 3.2 volts peak to peak and another 3.5 volts peak to peak. Okay, that ends the gain. Here's here's where I'm unplugging and plugging in the USB to monitor switch bounce or plug bounce. So here's 14 volts at 550 kilohertz. That's what I get when I'm unplugging and plugging in the USB into the wall socket. Here's another test. I did approximately 200 tests in all with the USB and the 5 volt power supply from the CIE Personal Lab Trainer. Here's plug or switch bounce, plug bounce or switch bounce. Here's another test. This is at 9 volts. Here's at 10 volts USB. Here's some more USB, 15 volts. Now this is this is a 5 volt from the Personal Lab Trainer. So I'm taking some tests with the and all this is going to be in the final write-up. Here's where I'm turning it on. This is what it looks like when I'm turning on the switch. And some more stuff. This is what it's going to look like on top of the box. These are just copies of these are these are already printed out on laminates. I'm just I don't really like the way it's being adhered to the box, but it's good enough for, I guess, this final project, I suppose. Uh, and that's it. Boom, boom. One last thing. Here's my project file that I started when I first started this project. I've got these folders, and in each one of these folders I've got all this material. I just wanted to show this, just to show it's I got stereo jack, I got a Libre capacitors, DC to DC converter stuff, and this is the file where all my AVC, CIE stuff is located. Images, HTML, hardware. I got the box, capacitors, connectors, inductors, op amps, power supply, resistor switchers, transistors. Front Designer is a program. Eagles, AVC, dip trace, projects. Okay, that's it. Thanks.